what would happen? What would happen? It would continue rising. The temperature would continue rising. Do you understand?
Yes, miss.
Next question. Can you solve the table? Huh?
Miss, separation for C to D, the particles will move apart and gain energy.
Let's name. See, this is when I started the lesson and I told you each question and each word is important. Let's sum it up. This is solid. This is have both states, solids and liquids. This is gas. Here, liquid and gas, and here are the gas states. Do you understand?
Yes.
So far, do you understand? Let's see the question. The question is asking as for the distance between the particles. Did I tell you what happens to the particles? You would say, yes, particles would gain energy. They would move apart. They would break the bonds and they would separate. But this is not the question. The question are asking about the distance between the particles in the region C and D. C and D, I understand that they are, the particles are the liquid particles, or the state is the liquid state. So what would be the distance between the particles? The question is clear. Distance between the particles in the region C to D. So I have to understand that from C to D, it's liquid. Then I can discuss the distance between particles. Do you understand, Alex?
Yes.
Huh? So can you tell me? We said it at the beginning of the class. What are the needed words to describe the distance between the particles?
They are randomly arranged.
And, yes,
And
close
together.
and touching.
Yeah.
Close and touching. Why I did not mention randomly arranged? Here is not asking for the arrangement, whether they are randomly or not. But here is asking for the distance between the particles, the separation. Are they touching or not touching? Do you understand?
Yes, miss.
So, Alex, a word might change the whole meaning. If I asked for the arrangements, you would tell me regularly or not regularly arranged. But here I'm asking from E to F. From E to F. So, E to F, what state is it?
It's a gas and they are far apart from each other.
Yes, they're not touching or far apart. Do you understand? By time you will learn to understand the questions, okay?
Yes, miss.
So what's the movement of particles?
Miss, in E to F, it is random and fast.
Yes. In all directions. Random, fast, and in all directions. Excellent. You have 2 points to write. Why? Because I have 2 spaces. And 5 marks. 1, 2, 3, 4, 5. Okay? 1, 2, 3, 4, 5. Huh? Can particles move apart and fill any volume?
For the liquid, they take the shape of the container.
Read carefully. Is the question asking you for changing shape or changing the volume?
changing the volume.
So can you say yes?
Yes.
No. This is the liquid state. Liquids can change volume or can change shape only.
Shape only.
So it's being specific. Can fill any volume. Yani this means, can it change its volume? Can it change its volume?
No.
Do you understand?
Yes, I do.
Okay. Do you understand so far?
Yes, I do.
Okay. Let's take something else. What is next? We know that particles are in continuous motion. This means the particles are moving all the time. And the particles, if they are in continuous motion, solids they have limited motion. The particles of the solids, the particles are limited because they vibrate in their place. But liquids and gas particles, they move randomly. And when they move randomly, they start to collide and hit each other. Do you understand?
Yes.
That's why when you get a leaf and you put the leaf on the surface of water, what happens? The piece of leaf keeps moving. Why? What makes the leaf move? What makes the leaf move is when the water particles hit each other and they start to move the leaf with it. Do you understand?
Yes.
When there is dust in the air, you can see the dust particles moving. Why are the dust particles moving? Because the air particles, they are moving in all directions, hitting each other, and they are moving the dust particles together. So the motion or the random motion of liquids and gases, it's called diffusion. So why diffusion happens? Due to the random motion of particles. Do you understand?
Yes.
So, for example, when you put on perfume, why do I smell it across the room? Because the perfume is gas. The gas particles of the perfume, they hit each other and they collide with each other and they start moving randomly and they move across the room. Do you understand?
Yes, I do.
So if I want to observe diffusion, I can observe diffusion through liquids and gases only. Okay? Okay?
Yes, miss.
So if I have a glass of water, and I start to put, what happens by time? This drop of ink, it's made up of liquid. It starts to collide with each other and it starts to diffuse. And by time, the liquid starts to become more and more red till the cup starts to become fully red. Do you understand?
Yes.
What makes diffusion faster? What makes diffusion faster? Factors affecting the rate of diffusion. What makes particles diffuse faster than the other? The first thing is the mass of the particles. What do you think? Heavier particles diffuse faster or lighter particles diffuse faster?
Lighter particles.
So as the mass increases, diffusion becomes what? Diffusion rate decreases. And actually, scientists had a famous experiment to prove this. They got a tube. This tube, they put at one side a gas called ammonia, which is NH3. And they put other side another gas, which is HCl. Both gases will diffuse, so both gases will move. But the mass of ammonia, it's not like the mass of HCl. How would I know the masses? I can know the masses from the periodic table. If you look, the one nitrogen weighs 14. I have 3 hydrogens. The mass of each is 1, so it's 1 times 3. So the total mass of NH3 is 17. While the mass of HCl, it's 1 plus 35.5. So the mass of 1 HCl is 36.5. Which is heavier, the NH3 or the HCl? Which is heavier, the NH3 or the HCl?
The HCl.
Okay. Which would diffuse faster? Which would move faster?
The NH3. Because it has a lighter mass.
Yes. So which would move to a longer distance? It's the NH3. Do you understand? So this means that the NH3 would move and reach the HCl first. Do you understand?
Yes, miss.
When NH3 meets the HCl, it starts to form a compound called NH4Cl, which is the white smoke. So the white smoke, according to this, would form near what? near the HCl? Because what moved closer? The ammonia. Do you understand?
Yes, miss.
So the same idea would come, and it comes a lot during the exams. But it's not the same example. It's not NH3 and HCl. But it's the same idea. It would bring you two different compounds with different masses, and you would guess which would diffuse faster and which one would move to a longer distance. Do you understand?
Yes, miss.
So this is the first factor. The second, when the temperature increases, the particles would have more energy, and then when they have more energy, they will collide more frequently. And this is very important, the word more frequently. This means more collision in a unit time, in a certain time. More number of collisions in a certain time, and when they collide more frequently, diffusion rate increases. Do you understand?
Yes, miss.
So what would be the third factor? It's concentration. When the number of particles increases, when the particles number increases, the frequency of collision also becomes more. And when the frequency of collision increases, diffusion increases. Do you understand?
Yes, miss.
So let's revise together what we took so far today. What did we take? We take the difference between solids, liquids, and gases. What did we say? Solids, they have strong forces of attraction. They're held in a fixed position. They do not move. They have definite shape and definite volume. Do you understand?
Yes, miss.
Remember, if I'm asking about the arrangement, you would say regular arrangement. If you are asked about the spacing between the particles, you would say touching with strong forces of attraction. If you are asked about the motion of the particles, you would say what? Vibrating in place. Do you understand?
Yes, miss.
What happens when the particles are heated? They vibrate more, they expand, and when they meet, vibrate more, and they become melted. They move apart and they become melted. Do you understand?
Yes, miss.
Liquids. What about the arrangement? They are touching or irregularly arranged. If I asked about the arrangement, you would say touching or irregularly arranged?
Touching in a random arrangement.
تاني لو أنا بتكلم arrangement random. If I asked about the spacing, you would say touching. Do you understand?
Yes, miss.
The particles, they slide past each other. Do you understand?
Yes.
So gases, there are no forces of attraction. They have free to move. They are not touching. They have no definite shape or volume. This is the heating curve. Particles gain energy, they move faster till they reach what? The melting point. This here, the temperature is constant. The temperature does not change. And I have the two states, the solid and the liquid states. Here, there is the liquid. Here, it's the boiling point. Here, I have the process which is boiling. The temperature is constant. And I have the two states, the liquid and the gas. If you do not understand, tell me.
No, Miss, I understand.
What can you see? What happened here? What phenomenon is expressed here? I had a dot of ink and then it spread throughout the liquid.
Miss, you're not sharing your screen.
هو كل ده I'm not sharing a screen?
No, Miss, but I heard you. I thought you were talking.
No. I was explaining through PowerPoint. Are you sure?
No, Miss, I can see that.
What phenomenon is shown here or expressed here?
The diffusion.
Excellent. Diffusion. And this is very important and it's out of 2 marks. If you want to define diffusion, how would I define diffusion? It's the movement of particles from area of high concentration to an area of low concentration until they are evenly spread. So if I asked you what is the definition or define diffusion, what is diffusion? Is the movement of particles from an area of high concentration to an area of low concentration till they are evenly spread. Do you understand?
Yes, Miss.
But